India's AI Stack, Bridging Government Vision with Enterprise Needs. My name is Aman Raj Khanna. I'm a partner and managing director for India at the Asia Group. Also my privilege to be a moderator here today. I have to say the energy here is still so palpable, even after 5 days of this. So it's absolutely brilliant to be here with you all. We've had a truly fascinating moment in India's AI ambitions. Some massive policy announcements. We just had Pax Silica announced this morning, very exciting indeed. Significant infrastructure investments. Brad Smith, if you heard him yesterday, Microsoft announced $50 billion in the Global South alone, after $20 billion that has been announced for India. Google, as you know, $15 billion. And growing enterprise adoption. Anthropic announced its partnership with Infosys, Tata, OpenAI. I'm sure you're all watching this. But announcement is one thing, deployment and then achieving scale quite another. So that's why this panel matters. Today's conversation brings two critical perspectives to this fundamental question. What does it take to translate that vision into adoption and scale? One of my two distinguished speakers brings unparalleled insight into infrastructure being built through national R&D institutions. The other sees the reality of what India's largest enterprises actually need when they deploy AI. So we're here to have an honest conversation about these two tracks. Where do they connect, and perhaps where they don't. So with that, let me introduce my distinguished panelists. First, I have to my immediate left, Mr. Vivek Khaneja. Vivek is the Executive Director of the Center for Development of Advanced Computing, CDAC as it's known. And CDAC has built the Param Supercomputing series, providing AI compute infrastructure for government departments and national missions. It conducts cutting-edge research into high-performance computing and cybersecurity, and also trains thousands of engineers annually in advanced computing and AI. Vivek, of course, has held multiple senior leadership positions within CDAC and has guided national initiatives in these critical areas. Welcome, Vivek. I also have to my far left, Nitin Bajaj. Nitin is Director of Sales for Conglomerate Accounts at Intel India. He leads Intel's engagement with India's largest enterprises on their digital transformation and AI adoption journeys. He has over 28 years of global experience in sales and technology leadership and orchestrates a broad partner ecosystem. These include system integrators, ISVs, cloud providers, to deliver Intel-based solutions spanning cloud, AI, HPC, 5G, edge, and end-user computing. So in summary, he sees firsthand what drives enterprise infrastructure decisions and what actually prevents companies from moving AI from pilot to true scale. So with those introductions, let's get right into it. Vivek, why don't I start with you? So here's my first question, Vivek. CDAC has built Param Supercomputing series and AI compute infrastructure. What compute capabilities does CDAC actually provide today? Who uses them, for what workloads, and what are the key constraints that you see operating within?
Okay, thanks. So as you know, CDAC is a scientific society under the Ministry of Electronics and IT. And one of the mandates that we have is to build supercomputing capacity in the country. This is the mandate which is given to us under the National Supercomputing Mission, where we have developed a series of supercomputers under the brand name Param. We started in late 80s, starting with the Param 8000. And now we have the Param series of supercomputers which are installed with about 48 petaflops of overall performance connected over the National Knowledge Network, or the NKN as it is called. This capacity is going to be augmented to about 100 petaflops by the end of this year, with 60 installations. Most of these installations are today being used by researchers. About 15,000 researchers fire jobs across these machines on the national NKN. A lot of it is being also used by MSMEs. For example, we have opened Param Utkarsh, which is housed in our CDAC Bangalore Center, for use by startups and MSMEs. The kind of applications that run here include drug discovery, bioinformatics. We have protein folding, molecular modeling, you have weather prediction. So, I mean, almost all number crunching problems, oil exploration, finite element modeling, computational fluid dynamic problems. So all such problems are being run across these clusters by researchers. We also have a lot of expertise in various domains which we have developed in-house over a period of years, where we are hand-holding a lot of these agencies. A lot of government agencies are working with us on this.
Thanks so much, Vivek. Lots of threads to pull on there, but for a moment, let me go to Nitin. Nitin, you work with some of India's largest enterprises, some of our national champions. So when these enterprises commit to AI, which you must have seen increasingly so, what are some of the actual barriers that prevent them to move from pilot projects, to some of those production scale deployments that everyone envisions, especially at, events like this?
First of all, thank you for inviting me. It's a privilege to be here and talking in front of such an esteemed crowd. So basically, I think I'll kind of break this into 2-3 pieces. One, be it Indian enterprises or be it global enterprises, I think everybody is grappling with the same sort of a problem statement. And everybody is trying to find those use cases which are very, very pertinent for their own enterprises. And some certain enterprises are into manufacturing domain, some are there in the retail side of it. And so the typical use cases that they have could be around smart manufacturing, smart retail, or specific GenAI use cases where they want to do a lot of document search. They have to have fine-tuned search on the policies, the TNCs and things of that sort. So essentially, the way you see it, I see it in twofold. One, they are looking at the speed, and everybody is trying to figure out the best ROI. So I think the biggest gap today is what to use, whether to use it on-prem or whether to go on cloud, use open APIs which are available to them. Then once those use cases are ready, as you said, from pilot to production, what is the final cost of that deployment? And then the third angle that comes in is whether to kind of centralize all of this or to take it to the edge. So there is no single answer. And when you think of all the ecosystem providers that are there today, be it from silicon to ISVs to system integrators, everybody has a pocket of expertise in their own sense. But today, there is no single formula. And the entire AI journey is changing so rapidly. Models are being dropped at a speed of light, and then the entire from silicon to OS to everything else, the whole ecosystem is changing so fast that even the enterprises are trying to figure out what is the best deployment model for them, what is the best ROI that they can get out of it. But in the midst of all of this, in pockets, a lot of these enterprises are trying to see what are the specific use cases that they can bring to fore that can bring some incremental benefit to whatever operations that they are running in their organization. Now, I can give multiple examples to it. For example, in a manufacturing domain, there could be surveillance kind of use cases, multimodal use cases. There could be use cases around how to look at inventory and then how to look at complete digital twin, a dark factory kind of a scenario. In case of retail, it is all about, say, it could be around preventing the thefts, the pilferation that happens, or doing customer analytics. And then, as I said, a lot of document search kind of examples are going on. But in most of those cases, the whole decision making is between edge versus on-prem, cloud versus sovereign data centers, what kind of models they should use, and how to find out the right ROI, which is where we feel frugal AI is what we kind of propose to the industry. And I'll talk more about that maybe later. But what is the best deployment model that can really help an enterprise scale at a level, at a cost point, which is really making sense to them.
So let me ask you a very quick follow-on question on that. Do you see that Indian enterprises are increasingly sophisticated in making these choices? And of course, Intel works globally, right? So how does it compare in terms of its maturity, sophistication, compared to the other markets where Intel also operates?
Clearly, in terms of use cases, I think we have the edge. But again, the veracity of data, it's a big problem. Second, I would say that these enterprises, when you think of it a year back, almost everybody wanted to buy GPUs. And a lot of these enterprises have bought systems which are powerful enough to run all kinds of use cases. But still, they are in that pilot phase because, again, because of that ROI factor. So things are maturing. Of course, enterprises are becoming smarter. From LLMs, we are now looking at SLMs. So they are trying to kind of figure out the right silicon where they have to kind of land their workloads on. So as things are emerging, I think things are getting better. But yeah, it's still some time before you see those live deployments coming out for the benefit of larger audience.
Sorry for interjecting. I think just to add to what he just said, we are seeing a lot of places where people are not being able to come out of the POCs. I mean, I think one of the major reasons that, at least personally, I have seen is that people are very happy with the POCs. They can train them on curated data sets. But once it actually goes and hits real life situations where the data needs to be cleaned up, it's not clean. You have no proper experience in actual deployments of the MLOps. You have done it in a canned manner. Then suddenly the reality hits that no, it's not that simple. And as you talked about the ROI, then you have to make those choices, whether I should have an on-prem this thing. Do I really need a GPU for my problem? Or can I work across multiple VMs on a simple IT infrastructure? So those are the choices that hopefully in the next coming years, intelligent choices will be made. We will start to see more MLOps engineers coming out and deploying these things at scale, because POCs is fine, but the real revenue will come only once you actually deploy it at scale.
Understood. Thank you so much for those perspectives. Unlike yourselves, you're both technologists. I'm a little bit in the policy space. I'm in the fringes of this. I work on tech policy. And I haven't had a single conversation here with a foreign investor which hasn't talked about sovereignty or dependency. So I'm going to bring my next question. I'll bring you over to my area, because I'd love to pick both your brains on this. So Vivek, let me talk to you about this first, right? So India talks about sovereignty, but CDAC still relies on global technology, right? Whether that's chips, systems, software stacks. So realistically, what can India build domestically versus what will we always need to source globally, right? And where should we focus our capabilities? So question to you as someone who's really on the cutting edge.
Okay, so let me answer that both technically and politically correct way. When you talk of sovereignty, let's see what does it really mean. Do you want to be completely independent in the entire vertical, right from silicon up to the application? Is that really possible, right? Let's say I need to design a GPU. It's a good aspirational goal, but do I have the wherewithal today to do the entire thing in-house? Probably not. I don't have the IPs. We can start, definitely. We don't even have today a fab that can give me a 3 nanometer or below production capabilities and packaging capability. So I think a more pragmatic approach is to have maybe the silicon coming from outside, and everything above that should be under my control. So you should be able to control all your critical choke points. Yes. So that's the model that India AI has taken. For example, they have created a farm of GPUs which are available under the control freely or at a reasonable cost for the developers. The models which are being built on top of that are under your control. How those models are going to be orchestrated is under your control. The applications that will use those models is under your control. So for me, that is the sovereignty where you are getting the maximum ROI. Should I really be competing against an H100 or a B200 from NVIDIA? Probably not in the short term. But yes, as an aspirational goal, just to let you know, CDAC is designing its own GPU based on RISC-V. We will probably have something by the end of 2029-30. But then, till that time, we really need to have a lot of this entire stack under sovereign control, maybe using chips from outside, whether it is NVIDIA, whether it is Sapphire Rapids or Granite Rapids from Intel, or from AMD. But everything above that should be, all my critical choke points should be under my control.
So I have to compliment you. That was a very candid and pragmatic answer. So compliments to you. Nitin, can I reframe that question a little bit for you? So, there's, as you know, in the same vein, there's a significant policy focus on data sovereignty and data localization as well, right? So when your enterprise customers are making AI infrastructure decisions, how much do these factor into those choices? And how do they compare with cost and performance considerations as well? So has this calculus shifted with some of the policy developments that we've seen over the past couple of years in AI?
Well, I would say not really. So it all depends on the industry that that enterprise is in. For a banking industry, for healthcare industry, data sovereignty is very, very important. For a manufacturing industry or for any other, say, retail or any other industry, they are trying to build use cases on the cloud because that's where they feel that they can build those use cases very, very quickly. They can simply call the APIs available there, and then they see that the performance is much better and they get better accuracy. So it's a mix of both. Now then comes again, even in a manufacturing environment, as I was calling out, in an OT environment, a lot of these manufacturing firms would want their data to reside within their perimeter because it is so close to them. Then again, when it is coming to deployment side of it, they're again looking at an edge deployment which becomes within the perimeter. So it's a mix of both. Now, finally, again to the point that I was making in the beginning, anything that has to scale, the price becomes a key driver. So it is about, okay, I have a model that I have kind of fine-tuned on the cloud. Now when I have to take it to deployment, can I use something locally which is available today with me without making a lot of investment? And then can I scale it? Which is where when Intel is talking about it, we basically kind of focus on frugal AI. Today, the Intel Core and Ultra Core CPUs, they have a GPU, NPU, and a CPU all combined in a single processor, which allows you enough capability to run maybe a 7 or 8 billion parameter model. So the typical requirements that you will have on the edge are very well suited on this CPU itself. And when it comes to a data center side, the Xeon 6 processors today are able to run a 20 billion parameter very easily. They can go up till 80 billion parameters depending on the specific use case. So do I need a GPU in every instance is the first question that we are trying to ask. And today everybody has a CPU in their environment. So can they reutilize that? And can they test it out? Can they look at performance levels? One example that I can kind of discuss with my customers is, if you're looking at, say, a prompt-based engine where you need to do a document search, typically human eye can read about 10 prompts in a second if somebody is a fast reader. Now, if a processor can give you 15 to 20 prompts, is this good enough as a performance for you, or do you want 200 prompts in that particular second? Maybe 15, 20 prompts is good enough. So that's where the cost versus performance comes in. That's where one has to be very, very calculated in terms of what is their end use that they are looking at and what would best suffice that particular usage. So again, it's a mix of this localized data versus what can go onto cloud. And once you look at the scale of it, again, you have to look at the cost. Because when you're scaling it on the cloud, the cost may be very, very different from what you can get on the on-prem side of it. I'm not a kind of proponent of on-prem versus cloud. For me, I think both of them bring their advantages. But what I'm trying to say is the customer has to really look at what is their end use and at what cost they want to bring it, and there are options available.
Understood. So we need to diversify our approaches and have a product to mission fit, which
Very
is
true.
absolutely critical.
Think of it, in the past, everybody used to think only mainframes can solve the problem. Today, the applications are not only running, are no more running on mainframes. They came onto CPU level things, and then today we are looking at microservices. So everything has kind of evolved over a time, and same things are happening on the AI side of it today.
Understood. So one quick question that's on everyone's mind, and to both of you. From each of your respective perspectives, whether that's government R&D infrastructure or enterprise deployment, is talent and the capability gap still a critical choke point from each of your perspectives? So Vivek, why don't I start with you on this?
It is. It is. It's unfortunate, but yes, it is. I mean, we do find that we have a set of very bright engineers coming out, but most of them are trained in good theoretical understanding of what machine learning is. They are good at mathematics, basic understanding. But when it comes to actual deployments on field, I think that's where we are lacking. Maybe we need to have a serious look at our curriculums in the colleges to see how do I train large models, how do I deploy large models using MLOps? Because today, as I said, I mean, most of these kids are working on curated data sets. They are working on some standard test cases and test and validation cases. But when it comes to real life, life is not that rosy. I mean, you have data which is missing, you have data which is skewed, you have data which needs to be cleaned, I have real-time constraints, I have other security considerations so those are not a part of the curriculum, right? So that's where I think some capstone projects where you are able to handle petascale data needs to be put in place. Theory is fine, but still there's a lot to learn on the practical side.
I'll give a different perspective. The way I look at India versus all other countries, in other countries it's an aging population. For us it is a booming population at this point in time, which with average age of 13 to 25 or so, which is kind of exposed to AI. So maybe today we may see some sort of gap in terms of AI capabilities, but 2 years down the line or 4 years down the line, I think that will be bridged very, very quickly. So we have that benefit of demography here. In the short run, of course, as an individual myself, I'm also learning from the kids today how AI can be deployed. So gaps will be there, but I think this is a learning curve for everybody.
Thanks, Nathan. I want to get to just a couple more questions and then we'll try and be very quick. One I've been wanting to ask you, and one that I get asked often, is the energy and sustainability question. You know, supercomputing uses huge amounts of energy, can have societal impacts, right? CDAC's supercomputing, whether the large data centers that Intel perhaps works with. So how do we think about energy and sustainability implications, especially in the Indian context? So Vivek, perhaps with you.
Okay. So from my perspective, I look at it to be addressed at two levels. One is something that we have been doing. Coming from a VLSI background, I can tell you that there are today standard techniques which are being used in all SoC designs, which are power-aware designs. So you have multiple power islands, you have clock tree gating that happens, you switch off those codes which are not being used. So that's from a design perspective. But when it comes to the platform design, there are smart choices which are being made. For example, if I talk about CDAC solutions, today we are using liquid cooling as well as water cooling in a ratio of almost 70:30. And we are slowly moving entire thing to a pure liquid cooled thing. There are other advanced techniques which use only air cooling. So ultimately, what is your PUE will actually determine, so typically, we see a PUE of around 1.2 or so, as compared to a conventional water-cooled thing, which is about 1.4, 1.5. There are definitely green norms which are being proposed. I think the question here to be asked, and we need to do this kind of a benchmarking across all the models, is what is the energy that I spend per token for training or for inferencing? I think there should be critical benchmark. We need to seriously look at how I can optimize my models to be more power aware, can I have compressed models which take less energy? So yes, energy is one of the critical factors, and especially hyperscalers would need huge amount of power. I mean, there's this joke that we keep on saying that along with the hyperscaler, you also need to have a small power plant which needs to be designed together with it.
Thank you. Nitin, to you?
I'll have 2-3 points here. One, from manufacturing point of view, Intel is utilizing the latest technologies like ribbon-fed and PowerVia, which improves the power efficiency by 15%. So these are the latest technologies available. Second, I would say that we are running our own data centers, which are running at a PUE of 1.06, which is the most efficient power data center PUE that you could see. So there's a white paper on intel.com. I would appreciate if those interested can look at it. Third, I would say again, power is a problem, or is the first and the foremost ingredient to running those data centers. So one has to be, again, very cautious of what kind of models you are running and then where it is landing. So if you are able to be, if you are more judicious in terms of our selection, then of course we can save power in some ways.
So one final question. I realize that time's up. One question. Let's put this in, a quick sentence, if you can. When we assess India's, progress over the next 3-5 years, what does success look like to each of you, sir? In maybe a sentence.
Success for me would be AI being actually deployed in a lot of workflows and making the life much simpler and enjoyable for us.
Thank you.
For me, it is like when we were like about 150 in terms of data usage. Today, we are number 1 in terms of data usage. When it comes to increasing the generic intelligence of people, so today we are using media and for entertainment, all the data that we are consuming. If we can consume the data for improving the general intelligence of public, that will make a large-scale impact on the society and India at large. So in 2 or 3 years, if a sabzi wala can figure out how they can kind of up-level their state, that would be the best way. And then all the indic models and all the other use cases that are coming out should be able to support those. And then it will be a mass-scale deployment of AI across the board.
Thanks so much, Nitin. And I see that time's up. I wish we could, pick your brain further. But this has been a truly fascinating conversation. And thank you for being so candid with all your responses.
Thank you.
So please join me in thanking both Vivek and Nitin. Thank you.
Thank you. I would now like to invite Sangeeta Reddy, Joint Managing Director, Apollo Hospitals, to give her remarks.
Good, thank you. Sure.